We should be already live, as I can see in the screen down there. And this is Barton. Actually, let's introduce ourselves with our name. I'm Roberto Capodieci, CEO of Blockchain Zoo. Barton is the CTO of Blockchain Zoo. I think it's good, yeah. If I put my arm from here, I can even enter there, see?
It's like a TikTok video.
It's something amazing, the technology nowadays. So what we're gonna be talking today about the meaning of decentralization. And this is a very old, in blockchain years, article written by Vitalik Buterin, or as I'm dyslexically say, Vitalik Buterik, in 2017, about aspects of decentralization, which are very interesting point to analyze, discuss, and reflect on, because many things people hear, but they don't really understand, and many aspects of decentralization require some discussion.
He starts with a very important point. I think that it's always worth it for us to pay close attention to, which is that when people throw around the word decentralization, they're not always talking about the same thing, and this can be very confusing. Like I think in the very first, if we can go to the screen here, the very first diagram that he puts as an example, calls this a centralized, and this a decentralized, which has some fragmented pseudo-centers, and this a distributed network.
Now, but you need to read the phrase that it says above, says, but consider, for example, the following completely unhelpful but unfortunately all too common diagram.
And he goes on to note later that in a different forum, there's precisely the same graphic, except the words decentralized and distributed have been reversed from each other.
Exactly, which are also two completely different things, decentralized and distributed.
So, and I do think the point of this article is very well taken, that it's important when we're going to talk about decentralized things to be specific, because decentralized can mean a whole lot of different things. And so yeah, we were thinking maybe we could take today to go and break down a little bit of the different aspects of decentralization, or what it means in the most important categories. And so this guy's got it broken down into 3 core points, which we can talk about a little bit each. The first one is architectural decentralization. So this is the point that you have, in the same way that if you have a backup hard drive, because now you have 2 physical devices, and the chances that one of them is going to fail and the other one's not is higher than the chance that,
Both of them.
Yeah, exactly. So you have, and the more times you replicate this system and put it on more hardware, even to the sense, there's a reason that an airliner has multiple engines, and so that if one of them fails, the other ones don't fail. And it's unlikely that 2 of them are going to fail at the same time.
Can we apply this with girlfriends or wives? But the Muslims have 5 wives, 4 wives, in case one fails, there are the other 4.
I suppose you could consider this a form of architectural decentralization. If
you
really,
become decentralized.
If you are really committed to the analogy. And actually, we talk about, a little bit later, we'll get to one of the key problems with where people think something is architecturally decentralized when it might not be as they think, which is one of the most interesting points of this article. The next kind that I think is the one that probably, as you get more into blockchain, you start thinking more about this one than anything else, is what he calls political decentralization. So this is the idea that not only should the software be running on a lot of physical computers, those computers should be owned and operated by a lot of different people.
That's correct.
And those, not only a lot of different people, but a lot of different people who aren't in groups that can easily collude with each other, and that aren't in groups that have incentives to collude with each other. They should be a lot of really individual people from a lot of different... This is where you get kind of the major guarantee. Say, it doesn't matter how many computers the network runs on. If half of the stuff on the network belongs to the same couple of people, then those people will always have the power to take over.
Yeah, exactly, because it will be as if it's a single computer.
Yeah. And just to complete the intro here, the last one that he talks about is logical centralization. And this one, to me, was the subtlest of the 3, because it has to do with the structure of the data on the system, and whether this is where you think logical decentralization is the kind that happens on a Borg ship in Star Trek, where you could cut the thing in half and both halves still function as though they were just a smaller whole. So Vitalik actually claims in this article, if we look at his little breakdown here, he claims that blockchain does not exhibit logical decentralization. But when I tried to apply that analogy myself, I'm not 100% sure that I agree. I think, because he said a good way to imagine whether something is logically decentralized is if you could cut it in half and the two halves would still function independently.
Correct.
It seems to me that would be true of a blockchain. You have two that would go into a fork. If you completely severed the network down the middle, both of them would continue.
I think that's his point. The way to prove that something is really decentralized is that if you cut in half, the two halves lives independently.
Yeah. So I was confused in this particular article that he seems to act like blockchains lack this property because they all have some kind of central structure that they obey, or that they all together form one central database. For a counterexample, he puts torrents in the logically decentralized category as the kind of a network that's really none of them have any kind of replicated data centrally. They don't all keep the same thing. And so if you were to cut the torrent network in half, each of them would function completely independently with just whatever files is on that part of the network.
Okay. I wanted to zoom the thing, but I didn't activate the zoom function on this computer. Yeah. So I think that reading through his article, I actually understood that the differences between structural business organization when it's decentralized, so there is no central point of decision, there is a person or an office like an headquarter, but delegate the decision on the specific level, while the blockchain had a preset set of decision that all the nodes must follow equally in terms of in a different kind of structure. Each node can act in different situation in different ways based on what he come to. In fact, one of the interesting dialogue I had while I developed myself into cryptography, decentralization, and I always left on the side is artificial intelligence, which to me is more the buzzword of saying something that is not, because machine learning is one thing. Artificial intelligence to me is the consciousness of machine, right? The computer.
That's another word that has a lot of potential meanings.
Exactly. While in reality is just a very well formed algorithm that apply modules in order to react. It's not really artificial intelligence. But it's true that you can teach in terms, so you can process so many data that you extract some pattern that is followed later. And the idea was have a blockchain where the node at the consensus layer or at the smart transaction, or if you want the transaction processing, rather than following preset rules that are very precise, respond based on machine learning, given that each node has been trained differently.
Yeah.
Okay, per se, you have this potential artificial intelligence blockchain with 1,000 nodes. Okay, each node is trained on fruit. It's given like 1 million picture about fruit with the correct names of fruit, etc., but not the same set.
Okay. Yeah.
Has been trained with different sets. At this point, you submit a picture of a basket of fruits. And the transaction is requiring the node to answer what fruits are in the basket.
Which in machine learning is called a classification task.
Exactly. So each one will have potentially different answer based on the training, or they're trained to the top level, will give a correct answer, all of them. But in this way you can use the property of consensus mechanics to raise one layer up the artificial intelligence, the machine learning response, to train one more machine learning. So this machine learning is trained by the result of a majority of other machine learning. And this can escalate to n level, right? So you have both circularly, but circularly is going to happen that at the end everybody has the same model. because if you circulate it, but if you escalate it up to get smarter and smarter things, you will have the possibility to get artificial intelligence the self-train, so machine learning the self-train. Because in this method you don't need to have any more human to do all the heavy and expensive process of submitting,
creating a training set.
exactly. So that was a nice discussion I had. I think I was ready in my knowledge with machine learning as much as the other people were in blockchain, so we were both assuming things on the other side of the spectrum, how things can be implemented.
And I remember part of this discussion, and it made me think, because the combination of these two things, people love to put these buzzwords together. Come on, blockchain, AI, and when you really think about how they fit together, there's a lot of nuance in terms of how they properly fit. One of the things that comes up is, say, the thing you're talking about, say, having a set of machine learning algorithms that then feed into another layer of machine learning algorithms that feed into another layer. That's something that data scientists already do. They're experimenting with in a centralized context. When you talk about running in a trustless environment where anybody could be operating the software, then you come up with a very interesting challenge, which is when my node gets a chance to propose to the network that this is what its machine learning classified that as, how does the network know that I actually used a machine learning algorithm to come to that decision?
No way to know.
So in fact, if there was some kind of economic benefit at the end of how this classification task happens,
it obviously will be based on universities working together in actor they're potentially honest. It wouldn't be a
where they have some kind of system of credibility or law or something that
just because they're trying to all together produce the best thing. Anyway, we're exerting in a very particular, but the decentralization aspect.
Just really quick on this topic though, there was another cool possibility that we wound up in, which is that when we had this discussion, which is that machine learning essentially is a deterministic process, or you can set it up so that it's a deterministic process. So even though the way, say, a neural network is trained is very non-linear, it can still, even though it's hard to predict the outcome, it's still true that if you feed exactly the inputs in the same order, you're going to have precisely the same prediction. So it is theoretically possible to create a blockchain with a very particular, each node has a very particular machine learning configuration, and from the transactions that flow through, each node learns precisely the same thing. And the outputs of the decisions of this machine learning would actually result in a blockchain that's in consensus.
Okay.
Which is very highly redundant instead of distributed, but it's in theory you could use this to make a machine learning outcome enforced by the network as long as everybody plays by the same rules.
Well, as soon as somebody doesn't, it's cut off. So the same kind. So if you need to rely on machine learning for the outcome of something and guarantee that nobody is cheating on it, OCRing license plate to send a fine, for example.
You can use a blockchain to train the neural network itself and make sure that the whole blockchain trains the neural network with the same set of steps.
And then
any node that you run a transaction through, every node that goes in is going to make precisely the same prediction. The one who doesn't is out of consensus and he's cheating.
I need to download the model and we start from there.
Potentially, yeah.
So it can be a growing...
which in ZooBC would be in the state team. So it happens with the snapshot automatically.
So we can decentralize artificial intelligence, to use the bad term. We can decentralize machine learning and...
But like in this article, when we say that, we have to know exactly what it means to say that. So people start imagining a supercomputer that crawls over the entire planet and uses blockchain money to pay itself.
Well, if it doesn't bite, we are safe. So there is that camera that is particularly dark. I need to set up a better contrast and brightness.
Well, I think maybe you just like in a moody lighting.
Maybe.
So
So going ahead with the article of
so now we get to, I think, the part that was the most interesting. All of this is very interesting, but I'm not going to read it for you. We can put the link to this article somewhere, but you can search for Vitalik Buterin and decentralization. It comes up pretty quickly. So we talk about. I guess I should go in order. We talk about the 3 reasons for decentralization that he gives, which are so. And we often talk about this in blockchain a lot, right? Which is, why do computers go to all the trouble to do this? A blockchain does a job that you could do on a single computer running anywhere. Why do we take the time to split it in so many places and make sure they're owned by so many people who have some kind of financial reward? Like, there's so many complex mechanisms to take that one computer and split it out into a whole network.
Why decentralized? That's the question.
Yeah.
Okay, so then...
And this guy gives a couple of answers that we can discuss. But go ahead, give your answer first.
Okay, I want to really go down to the reason of decentralization, right? Decentralization is not something new. It's not always related to IT and computer. If you think the need of a society, for example, food, the way the food is provided is from many different sources. So if something happened to one source, crop goes in fire or whatever, there is still all the other sources to send in food. If it was centralized, there was a single source for the food for everybody, and there is a trouble there. In case of war, for example, the attacks and the bombing are done on the strategic points. One, for example, is the production of electricity. Nowadays with electricity, not much can be done. And this example from the Second World War, I think, in Germany, they thought they'd rather to have a central electric plant that produced electricity or convey the electricity for all the city, where the enemy can easily bomb that and leave the full city in the dark. And even if you have 2 or 3, they're still easy to be identified, located. They gave almost every house, using an engine from a car, the capacity to produce electricity for the household itself, but also in excess to be put back in the network. In this way, the production of electricity for the full city would have been completely decentralized and impossible to attack, because even if you attack one or one got broken by his own problems, he was keep providing electricity, and the place where the local production was broken will still have electricity from the grid from the other.
So fantastically, you've produced the first 2 points that Vitalik makes in this article in the same order, which are, first, with your farm analogy, you talked about if there's a fire at any one farm, the rest of the farms don't go, can still produce food. That's a property he refers to as fault tolerance. So the fact that you have a lot of different replicated redundant systems doing the same job means that a failure in any one of them doesn't prevent the rest of them from coming together and continuing to work. The second property, you used the war example and how the reason that they distributed the generators among all the houses is related to attack resistance, which is the fact that when you decentralize a lot of different points, somebody who wants to take this thing down has a lot of places that they have to destroy and take down instead of a couple central ones where they can focus their resources of attack. So in computer terms, we think of this like a distributed denial of service. Somebody has a giant botnet that they've hacked, and they want to use the low orbit ion cannon on some particular computer to take a website offline, right? But if that content or that service is being hosted by 10,000 computers redundantly, then their ability, hardly they can take all of these computers offline, even if they could identify them, which itself is questionable in some architectures. And the same exactly is true, I think, in your military analogy, that hardly they have the bombs to go and hit every single house.
But they can connect to the network and put inside very high electricity to make everything goes bad. As much as in a blockchain, if the protocol is not designed well, they can single attack in protocol level, but we're going to talk to this later.
Now,
there is a third point that Vitalik make, which is the collusion. So if you have one electricity production for the city, and the employee want to protest and collude and shut down,
I think I would love to use politics as the example related to collusion resistance, except as far as I'm aware, no political system on earth has successfully resisted collusion.
So it's important that the honest majority decide something. And if the full the full entity is split in two, there are two different decisions that can still follow. Let's say in the case of electricity produced in the house, they decide to change voltage. Obviously, if a single person decides to change voltage, it's going to find itself alone, isolated from the rest of the network. If half of the city want to change voltage, you're going to have two different networks, one with a voltage, one with another voltage. Or if the majority, then the minority going to adapt themselves not to remain excluded. So the collusion of few cannot...
Well, and I think he rightly notes in this article that collusion is the hardest to define correctly, because collusion is very closely related to cooperation, which ideally when you have a big network like this, the goal is to get everyone to cooperate together. And when you have a community of people who support a technology or support an idea, you want for them to be in connection with each other and in cooperation with each other in a positive terms. So I think he says the best we can define collusion is it's people who are cooperating with each other in a way that we think is bad.
Who think is bad? They must think is right.
Correct. And so it's much more difficult at the network level, the protocol level, to make a distinction, say a kind of a technical criteria distinction as opposed to some kind of moral judgment about who has the right, like what is it that's, you know, this well-meaning cooperation for the benefit of the network, and what is it that's selfish collusion. I think the closest he gets to defining it is collusion, you could say, is the cooperation of some actors who are trying to use a power or a connection with each other that is not in the benefit of the entire network, but only at the expense of the rest of the network for themselves. But it's a tricky one to define, I think. We run into this when we get into the 50% problem. You know, say you and I have gone back and forth sometimes about can you make a protocol, say Bitcoin brags that it would take a 51% attack, or really 50 plus. More than 50% attack. It takes a majority of the network, at which point, from the technology's perspective, if an attacker controls 50% of the computing power, democratically, he's in the right. If you had any kind of, you know, political parties having an election and one of them moves over 50% of the supporters, and you say he rightfully is that. And so is there any meaningful way to say a network where you have to have 75% agreement from the network to move forward?
Well, when you stipulate a company, you can set the voting power in order to process a decision of a certain level, of certain importance, to be 80%, that depends. So it's open to how things are decided at the beginning, and then obviously if you have 90% necessary majority to change things, and you want to change things to be only 50%, you need to go through the process of the 90% to move it to 50. So in a certain way, if a system has a majority of participants aiming to change it, and then at this point it will be changing in that direction, I think. But the point is true that if people can game this majority to damage the other parties by pretending to pay and then cancel the payment transaction, which is classic, is this to be considered legitimate just because the protocol is written to work in this way? In the past, we had this confrontation with religiously devoted to proof of work toward other kind of mechanics, and in front of the evidence of the fact that you can process an attack with the majority of hashing power or proof of work, January 2020, Ethereum Classic has been attacked successfully with the majority of hashing power, where somebody made consistent deposit in exchanges, withdraw after exchanging different currency, then rewrote with a high hashing power the Ethereum Classic blockchain, removing the transaction where you made the deposit in the exchanges. So the exchange have been robbed, let's say, of the Ethereum Classic.
With his Ethereum Classic and the Bitcoin.
Exactly, correct. So in front of this, which is an evidence, the people that support proof of work say, well, that's exactly what is made to do by design. But is that made to do that people can steal other people's money, or because democratically they can?
It's quite. If 50% of the taxpayers vote in a president that says they're going to give everybody else's money to them, I don't know. But I give an example of this thing when we were talking about the corporate boardroom and requiring 90%. But I'll make it a blockchain example. So many different protocols, different kinds of blockchains and similar decentralized technology that have come around now. They use this algorithm that's called Byzantine fault tolerant algorithm or something like that, PBFT, Practical Byzantine Fault Tolerance, I think it's called. And in this particular algorithm, the people who brag about it, they love to say this. They say, oh, we do better than in Bitcoin. With 1/2 of the network, you can take over the network. But with this PBFT, you have to have 2/3 of the majority of the network in order to get it to move forward and produce new blocks. 2/3 has to be in agreement. So
which means there's just
2/3 of the people. So if we turn this around the other way, what they're really saying is that if even 1/3 of the network decided not to participate, then the blockchain is stopped. It cannot continue.
You don't need
And the same is true, actually, in a corporate boardroom. If you have 10 board members and you need nine people to vote unanimously, then really all it takes is the collusion of 2 to prevent a measure from going through.
It's also true that if this is only related to a tax, let's say you say in the boardroom, to take all the money we have from the bank account, we need 9 out of 10 to agree. But to change, the chairs of the table, which are very cheap, only 6 out of 10 are enough, or even 4 out of 10 can have. So it's mistaken to use this majority to get things moving, to get things approved, because you actually give the power to the minority to block everything. But at the same time, if it's related to things that are damaging the community, let's say the full system, then so now is the definition what is a damage, what is not.
Exactly. It really gets into like a hard point about democracy itself, which is that this idea, which I come from America, and in our history we've wrestled with this kind of problem a lot. Surely lots of different countries and systems in the world in their own way, so if more than 50% of the people believe in something, does that make it right?
Oh, that's
that's a whole can of worms, right?
America being exporting democracy around the world so much that they left themselves without. That's true. In fact, oh my God, this I'm being very much criticized for this. But my point of view is that the perfect election, the perfect democracy, take in consideration the capacity to elaborate of a person, the IQ of a person, and how much this person is prepared in the topic they express the vote. For example, I need to vote for a president. Okay. First, I do a check to understand my IQ, which has a weight in my vote. And then check me on how ready I am on the 2 parties that are potentially to be voted. Do I know what they've been studying, what they do in life, etc., etc. If I am intelligent and know details of them, then my vote has a high value. if I am not so intelligent but I know very well, then I have a good vote as well. If I'm very intelligent but I'm not prepared about what I'm voting about, it goes down. If I'm dumb and I also don't know what I'm voting, they let me vote just for the play of it, but my vote is gonna have no value. And pretty much this is, I do believe, a mechanics that can be also applied for a new kind of consensus. Proof of preparedness, which maybe can apply in the blockchain where there is the machine learning inside, because that shows how the machine learning is being prepared, given that they're not synchronized. Anyways.
No, in fact, this is quite a contentious issue in America for anybody watching there, which is that, when the question there is that, I think it's a pretty intuitive idea that if you could measure who's better equipped to decide the president and who's not, then you would give them a weighted vote. The contentious part comes into how precisely it's measured and who is allowed to do the measuring. In the sense that people have questioned, for example, that people from different socioeconomic backgrounds respond to an IQ test differently, not because of the content of the IQ test, but because of whatever kinds of, historical ideals they have, whatever kind of style of thinking comes from that.
Which image doesn't match with the others, have much historical ideas. So that's the way Mensa measured the IQ of people. In order to be part of Mensa, you need to be intelligent, which is potentially is good for a lawsuit because that's very discriminatory. But let's pretend that, it's like when Hooters, the food restaurant chain in America, that was very proud because they had waitress with good shapes on, has been forced by the Congress to hire as many men as many. And they made a calendar with all the guys very hairy because, come on. So Mensa is a place for intelligent people, should be sued for discriminatory acceptance. But
how dare they not let the other low IQ people?
But this raises a very important aspect. To be decentralized system, you need to have no person that or entity that had the decision power on even how to evaluate the value of the correct or the wrong. Every blockchain is anyway designed by somebody. Bitcoin has been designed by Satoshi Nakamoto team. Ethereum, we have the leader Vitalik. And these people, whoever designed this, put the basis on the rules. But probably the ideal blockchain is designed in such a way that even the rules are chosen.
In fact, we've done some thinking about this. I would put a point on the previous comment about does a majority make you right in the second way, which is, or in what I think is a less controversial way, which is if you have a majority vote on the answer of 2 plus 2, and you have 60% of the vote put the wrong answer, does it make them right? No.
Okay. Well, no, maybe yes. This goes for language, for example. A lot of disaster grammar become accepted and correct by the mass using it.
Sure, yeah.
This applies to mathematics too. That's a very good point. What if tomorrow everybody is telling you that 1 plus 1 is 3?
You tell me I'm holding up 5 fingers.
There was this series called Twilight Zone. And I remember there was an episode of this Twilight Zone where this guy wakes up in a world where the vocabulary is all messed up. So people will go like, why is the refrigerator? Trying to say something with words that doesn't mean anything. And obviously to the viewer, everybody's crazy, but in the story, the guy is the one that has the word messed up, respect to the rest of the people, because
he speaks to these other people and they don't understand.
The other people understand each other by the messed up words, because they all have the messed up words. So you wonder, who's wrong, who's right.
Which in fact, so if everybody said 2 plus 2 equals 3, and you said, all right, well show me 3 rocks, and they put
That put 6 on the ground.
then you know that in fact there was just the symbol 3 that's been replaced, but the concept still refers to 2 pairs of 2.
Okay, so this is
Anyway.
true. This is beautiful because mathematics is the universal truth. There is no opinion
Yeah.
in mathematics, and this is what we love about blockchain. Is the fact that the structure, the rules for agreement
Are enforced.
are enforced by
mathematics.
mathematics. So doesn't matter how somebody interpret them, but the result has to be correct. That's the biggest power.
And say praise to whatever your deity or non-deity every day that we live in a universe that has some grounding in objective truth. Because otherwise, if there weren't some kind of mathematics that sets a consistency between each of the things, then we really would, I don't know if we would exist at all, or we would exist in a place where only your thoughts create everything that happens the minute you...
So they say doesn't matter which is your religion, doesn't matter which is your language, 1 + 1 is 2.
There's a philosopher once that said, even God cannot create a triangle whose inner angles do not sum to 180 degrees.
Right.
Now, of course,
Unless he uses a different
that
way.
was before we discovered non-Euclidean geometry.
Those.
But his point was well taken. if you make a triangle on a globe, then each of the inner angles is 90 degrees.
In fact, there is a nice riddle that goes, you go south 1 mile, you go west 1 mile, you go north 1 mile, and you are at the starting point.
But you have to be at the pole.
You need to be at the North Pole, correct? In this way, the only way you're making a triangle on the globe. 3 sides of a square, ideally, is actually a triangle if you are on a round surface.
Yeah.
Anyway, we're digressing. But back to our friend Vitalik that writes interesting things.
So finally, we get to the most interesting part that he talks about in here, which is... Because remember we put kind of an asterisk when we talked about fault tolerance above, which remember fault tolerance is the point that when you have a lot of different computers or a lot of different pieces of your system that can all fail independently, the chances that all of them fail or enough of them fail to disrupt the system are much lower. So there's an exception to that, which is this thing that he refers to as common mode failure. And that is that maybe, so I think he gives the example, in an airliner, that has all of these 4 engines, with the idea being that only one, if one's going to fail, only one is going to fail, and the other 3 can fly the plane. Those 4 engines were probably produced at the same plant, and that plant, in the week that they were stamped and approved, could have had a rogue employee who put a defect into each one, the same defect, so that they all fail at the same time. Or in fact, the more relevant example for blockchain is that if a blockchain software, a blockchain is really more of a protocol, which is this kind of ethereal thing, it's like it exists in logical space. The software itself is just one incarnation of a thing that can process those rules. If all of the software is developed by, it's one piece of software that 10,000 computers run, then either those pieces of software can have a bug, and they all have the same bug, which means that somebody could abuse all of them the same way, or the same very natural occurrence on the blockchain, some particular set of circumstances causes all of them to fail in the same way at the same time, or even they could all have a backdoor, for example, if the people who produced the software were malicious. And so just running on 10,000 different computers does not by itself make it, it's not only about being decentralized how the thing runs, it's also being decentralized in how it was produced and how it was vetted.
So next time you catch a flight, make sure to check that one engine is from Rolls-Royce, the other engine is from Fiat, the other engine is by General Motors. And
it's going to be a super weird looking airplane,
but
super safe.
And yes, that's another very important thing. I personally follow all the GitHub repos of Ethereum before Ethereum was released, and looking at the daily things and looking how they were throwing money to get anybody involved to do the whatever different language. At the time I thought they were crazy. It's a mess. And actually, that's been the big power of it because they came out with some failed, some didn't succeed, some took longer of other, but they had several implementation of the same protocol made with different languages, they run in different kind of computer, etc., etc. Then you have so many nodes, they are very different one from the other. So attacking them is pretty much impossible because you will need to find all the issue in all the software version, all the different deployment on different operating system, etc., etc. That makes a very strong and secure blockchain. So much that if somebody freely independently implements something that is compatible, that's even more secure than if he's copying my code. So I had to appreciate that, and that's one thing that some blockchain don't do, and they all use the same software. It's not the case of Bitcoin, which has millions of people contributing in different ways, different solutions, but some miners one node implemented by the same people, and everybody want to run the node, they only download that node. There is no alternative versions. With our project, we're working very hard to make it very easy for third party to take implement. There is all documentation in the it's funny enough because a project that I've been very close to even didn't document the code purposely to make it very hard to implement, modify, exactly, or replicate it because they were jealous of their invention. And this is wrong because it makes this weaker.
And in fact, the thing that we produce for our blockchain, really the work that we've done and the thing that we've produced takes the form of a protocol. It's this ethereal, logical thing that exists in mind space and in some documentation. The code we write to actually execute the protocol, as a company, we first produce what we call a reference implementation. And so it's the reference implementation because it gives an example of how to execute all the rules. But we hope, in order for the security and decentralization of the system and to avoid this problem of common mode failure, that multiple people will actually care about the technology enough to implement their own versions of the same protocol, make them all interoperate, so that if any one of these implementations has a bug in it or some kind of backdoor or some kind of problem and they all get taken offline or co-opted or something, that the rest of the network continues to operate without failure.
You know what? We take 3-minute break and we're gonna get back soon. And we're back here. Thank you for waiting for us for our small break. And we've been talking for quite a long time, and for quite some time. We need to wrap up this thing. So
there's just so many interesting things to say about decentralization.
Decentralization is the way to go. I think that as we enter this third industrial revolution, right, which is the information age. Information age was stage one was the digitalization of data. Whatever is analog, radio waves, music, even video transmission became digital. So it started transforming numbers, and number is transforming the image. We have digital photography, we have CD, we have digital radio, we have MP3s, and so on. Now we are in the phase two, and the phase two is about decentralization. So, and the blockchain has a big power to make a digital asset unique. Because an asset that is digital is the beautiful things to own a painting made by an author is that in one piece. You painted the thing, it's physically with me, nobody else has it, right? But if a photographer make a digital photo, you can make 500, 1 million, 1 trillion copies of it, and nobody can control this. An MP3 file, I can copy the MP3 file and give it to 2,000 people. There is no uniqueness. But if I have a Bitcoin, once I give my Bitcoin to somebody else, I don't have it anymore. And this is the capacity to create a method to have singularity in the digital asset world. And this is magic, and is what allows us to decentralize, because we don't need any more people in a central place to hold the guarantee for us, the security of the digital things, right? Is it banks for digital money? It is provider of images, whatever it is.
No, I mean, I think it's quite an interesting philosophical rabbit hole in general. In many ways, life in nature is built on decentralized systems. But there's always a play, a flux, a to and from between decentralized and centralized. Say, the very first organisms that existed were tiny little central units, And then the very first kind of organisms they formed were things like funguses, which were these giant decentralized networks that work together, but there's no discernible center of them. Then they start to become animals, more like us, which have... So, your body is made of these trillions of different cells, which each act individually in some sense, but they're also structured in a way that gives your body a kind of a centrality. There's one part of the body that centrally handles this job, and the brain centrally handles this job. But if you go to any particular group of cells and accidentally damage a few thousand of them by cutting your hand, then they know how to replicate themselves, and the genetic information is replicated in you 1 trillion times to make up your entire body. And it's and I think that technology has this to and fro as well, in the sense that so at first technology, say before the internet and things like this, was necessarily decentralized in a lot of ways. You built a device, you had a factory that makes devices, they all go out in the field and do some particular job. That ability to do work is replicated. Eventually we started to get things like connectivity, and then it started to be easier for efficiency. We could do things like say, all right, well, here's one point in the center, and everybody connects to this point, and everybody reads from this point, and now they're all connected. And now we're getting to the point where we say, okay, that was nice back for when it was the only thing we could do, but our power to do more is expanding, is increasing, and now we can accomplish the same goal of having everybody able to connect and everybody able to read without keeping everything in one place in the center that an attacker could put pressure on, that can fail with fault tolerance, that somebody can collude how they're going to control on it. We can solve these remaining weaknesses of this central point by pressing it out into an entire network of points without losing the power that anybody can connect it and write to it or read from it from anywhere, without losing their confidence in the quality of the data in the system.
Wow. I think we are moving toward a very interesting future. And like everything else, people get used to those things. They use them without even realize. As I said the other weeks ago, I met somebody that was using Facebook in their cell phone. I said, you have internet? No, I don't have internet, but you're using Facebook. Facebook works with the cell phone, doesn't work with the internet, right? Because sometimes the underlying technology disappears to the eye of the user. And this is what the blockchain is an underlying technology. It's not a finished product, meaning that is used to empower other solution. It's not a solution on its own. Let's say it's a tool. So things are going to be decentralized. We're going to get used to deal with decentralized things. We're going to buy art in a decentralized place. We're going to get fined by the police officer in a decentralized place. We're going to sell our house with a certificate managed in a decentralized place. And probably we will not.
Particularly important right at this moment is the idea that if a police officer takes an action, it's validated in a decentralized way that doesn't afford anybody the ability to cover or the ability.
Can you cancel the fine for me? Sorry, I can't. It's in the blockchain, right?
Yeah, that at least. But probably other ways that we can make use of this ability to make sure nobody's abusing their power within that institution.
Well, if you guys that are watching this have a particular suggestion for the next discussion, use case of blockchain, a specific use case analysis, then let us know and write it in the comment. We are at the conclusion on our 1 hour of conversation about blockchain, decentralization. Thanks to Vitalik with participating directly with this article that is available for everybody to read.
It's clever shit, check it out.
And
in fact, okay, my favorite thing that he puts in here is he's talking about the Bitcoin mining power. He says, can we really say that Bitcoin mining power is decentralized when you can put the owners of 90% of it in one room on one stage together and say that that's collusion proof?
There are many things to fix to arrive to the pure, real functional decentralization. We're working hard with it. Check Zoobc, ZOOBC is a new platform that is going to come out and play a very strong role in shaping the future of decentralization. All right, thank you everybody for following, and I guess we can say goodbye and talk to you next time. Yay!
Peace, guys. How do you stop?
This thing.